Yes, okay. Okay. Good evening.
Good evening.
Let me introduce myself. My name is Shamila. I am from Kollam. I have completed my degree in mathematics from Kerala University. I have a teaching experience. That's all about me. What about you? What is your name?
Okay, my name is Vidya.
Okay. Then move on to our topic.
Yeah, okay.
Today we are learned about the probability, the theoretical approach of probability. In your standards 9, you already learned about what is probability. It's clear.
Okay, clear.
What do you mean by probability?
Okay, probably. Yes.
Probability is a chance getting an event, chance of getting an event.
Oh, yeah.
Okay. Then we can see so many examples in our daily life about probability.
Okay.
One of the a coin is tossed. If we get head or tail, we cannot predict how we cannot predict what will occur. It's head or tail. We can't predict exactly the result.
Okay.
In this situation, we use probability.
Ah,
Okay.
okay.
Then move on to our topic. Firstly, we learned about some basic terms of probability.
Ah,
That is, first one is outcome.
yeah.
What is outcome? An outcome is a result of a single trial of an experiment.
Okay.
It is a result of a single trial of an experiment. Example, a coin is tossed. We get head or tail. Okay,
Okay.
these are the outcome. Head and tail are the outcomes.
Outcome. Okay.
Then second one is experiment. Experiment is an operation that produces well-defined outcomes. Experiment is an operation. A
Okay.
coin toss is an experiment. A die roll is an another experiment. Okay.
Okay.
Then sample space. What is sample space? The set of all possible outcome is a sample space.
Okay.
We get so many outcomes in our experiment. The collection of these possible outcome is a sample space. Okay, you understood?
Yes, understood.
Example: when you're rolling a die, the sample space is 1, 2, 3, 4, 5, 6.
Okay.
Okay.
Yeah. Okay.
Then what is equally likely events? Two or more events that have equal chance of occurring.
Okay.
When a coin is tossed, we get chance of head or tail. We get equal chance of head or tail. There are two events,
Okay.
two outcome, head and tail. We get the equal chance of head and tail. 1/2 is the chance of getting head or tail.
Okay.
These are the example of equally likely event. Two or more event that have equal chance of occurring.
Yeah.
Okay. Then move to our topic, the theoretical approach of probability.
Yeah. Okay.
What is probability? Probability is a quantitative measure of uncertainty. It predicts how likely an event is occur. If certainty, we can predict what will happen.
Okay.
In uncertainty condition, we cannot predict what happen.
Okay.
In that case, we use probability.
Okay.
Then probabilities are two types: experimental approach and theoretical approach.
Okay.
In experimental approach, we performing an experiment multiple times.
Okay.
Multiple times we perform an experiment,
Okay.
and then we observe the experiment and collect the data and analysis at the probability.
Okay.
And second one is theoretical approach of probability. Theoretical probability predict outcome without actual performing an experiment. Here we without taking an experiment. Here we use logical or calculations, mathematical
Okay.
calculations.
Calculate.
Based on logic, we find probability.
Okay.
Clear?
Clear. Clear.
Any doubt?
No doubt. Clear.
Uh, experimental probability, another term of experimental property is empirical probability.
Okay.
Empirical probability and experimental probability are same.
Okay.
How to calculate experimental or empirical probability? P of E is an event.
Event.
Then we calculate P of E is equal to number of times times of event E occur by total number of trials.
Okay.
For example, if a die is rolled, it is simple example. If a die is rolled 100 times,
Okay.
our event is the number of 4 appear 20 times.
Yes.
Then the P of 4 is equal to 20 divided by 100 is equal to 0.2.
Two. Okay.
20 by 100 is equal to 0. 0.2 is a probability of getting number 4 appears 20 times.
Okay.
Here we take an experiment 100 times.
Okay.
So many times we taken this experiment.
Yeah.
In another case, we can calculate simply using theoretical probability or
Okay.
classical probability.
Okay.
It is defined as the number of favorable outcomes by total number of possible outcomes.
Okay.
What is favorable outcomes? What we need in our experiment. So that is a favorable outcomes.
Okay.
Okay. Example: the probability of getting an even number on a die. Favorable outcomes are 2, 4, 6.
Okay.
All outcomes. What is all outcomes? Right. Probability of getting an number of possible outcome when a die is rolled. What is the number of possible outcomes?
Oh,
What are they? Sample space is equal to
okay. One,
so 1, 2, 3, 4, 5,
six.
6.
Okay.
These are the sample space.
Okay.
Here we getting an even number on a die.
Ah,
We calculate our event is getting an even number on a die. Then E is equal to set 2, 4, 6, this
yeah. Okay.
three outcomes.
Three outcomes.
The sorry. Then P of E is equal to number of outcome favorable to E by total number of possible outcomes.
Okay.
Here number of outcome favorable is equal to 3.
Okay.
Is correct?
Yeah. Correct. Three.
Divided by number of what
Six.
possible outcome is
Six. Okay.
our probability is 1 by 2.
Two. Okay.
Okay,
Yeah.
clear?
Clear.
Okay. Then we move to comparison of probability.
Okay.
If P of A greater than P of B, then the event A is more likely than event B.
Okay.
Here,
Yeah.
event A is more likely
Likely
than
to
event B.
event B. Okay.
Then P of is equal to P of B, the event A and B are equally likely.
Okay.
Okay. Huh. Then what is the range between range of probability? It's between 0 and 1.
One. Okay.
Probabilities also lies in 0 and 1.
Okay.
Between 0 and 1. Here 0 less
And
than or equal to
first.
P of A less than or equal to 1.
One. Okay.
Uh, uh, what is complementary event? If E is an event, if its complementary event is not E. If
Yeah.
the event not occur, E complement. Formula of finding E complement is equal to probability of E complement is equal to 1 minus P of A.
Okay.
We always subtract this event from 1. Total probability is equal to always 1, and
Okay.
this P of not E is equal to 1 minus P of E.
Okay.
Okay, here we example if the probability of a rain today is 0.3, then P of not rain is equal to 1 minus 0.3.
Okay.
We get the answer
0.7.
0.7.
Okay.
So, okay, then here we note the key points. Probability qualify uncertainty using the mathematical approach. When we use probability in uncertainty condition, we use probability.
Okay.
It can be calculated using empirical or theoretical method.
Okay.
Okay,
Okay.
it can be calculated using
Empirical or
empirical
theoretical
or theoretical methods.
methods.
Okay, the probability of any event range from 0 to 1. The
Oh,
probability of any event is oh, I can't hear what you
yes.
say.
Yeah. Clear.
Okay, the probability of any event that range from 0 to 1. The sum of probabilities of all possible outcome is always 1.
Okay.
Okay, okay. The sum of probability of a possible outcome is always 1.
One.
And then complementary probability is equal to P of E complement. Understanding?
Yeah. P of P complement equal to 1 minus P of P. Okay.
Clear?
Clear. Okay.
1 minus P of E. Okay. Then do these examples in your homework
Okay.
and tell me any doubt.
Okay. Ah, no doubt. Okay.
Okay, we will enjoy.
Yeah.
Thank you.
Okay. Thank you.